Hello, and welcome to Lesson 2 of the Enchanted Interpreter. In the last lesson, we covered printing and how we can format our print statements with escape sequences. Today, we're going to build on that quite a bit. We'll learn how to store information in our program, how to get information from the person running it, and how to combine the two in a way that allows us to make our programs much more dynamic. Before we dive into the content for today's lesson, though, I wanted to cover something I didn't cover in the last lesson: comments. A comment is a line in your code that the interpreter ignores when it runs. To create a comment, you just need to use the hash symbol. Anything following it will be ignored. Let's run our program. Notice nothing happened. The program ran, but there was nothing for it to do because it skipped this line entirely. Comments have a few uses. Here we use the comment to temporarily disable part of the code without deleting it. Say you're testing something and you want to skip a line for now. In this example, we have this line will print. Then we've commented out this line will not print, and then we have this line will print as well. If we run this now, we see the first and the third lines printing, and our initial comment and this middle line here being ignored. The main use for comments is annotation. You can use them to leave notes in your code to explain what something does or why you wrote it a certain way. They can be used to explain your logic to other programmers reading your code or even to yourself if you need a refresher. I've seen conflicting opinions about how frequently you should use comments in your code, but especially if you're just starting out, I say comment early, comment often. It really helps to keep your code easy to understand. I couldn't tell you how many times I've come back to a project after a long break and just thought, what was I thinking? And if I'd have commented, maybe I would have had a better idea. So do as I say, not as I do, and comment your code. To comment multiple lines at once, just highlight the lines you want commented out, and then use the control forward slash or command forward slash on a Mac. And you can also uncomment them with the same command. Comments don't have to be on their own line either. We can add a hash symbol here and say this is another comment. And if I run the program now, we'll still get the same result because this line is before the hash symbol and the only thing that's ignored is what comes after it. So they can be on their own line or in line as well. All right, with that out of the way, let's look at variables. So far, we've been passing strings directly to the print statement. But what if we want to use the same piece of information more than once? That's where variables come in. Variables store data that we can use and manipulate throughout our code. Think of them like a labeled jar for your data. Creating a variable looks like this. Here, name is our variable. It's the label on the jar. The equal sign is the assignment operator. It's how we put something in the jar. And then this is just a string. It's the data that's being put in the jar. Now, if I want to use that string, I don't have to type it out again. I can just use the variable. Here, I'm saying to the print statement, take this jar and print whatever's inside it. If I run my program now, we see my name outputted to the console. Say I want to print my name a bunch of times. Just pretend that 3 is a bunch. I could say print April, print April, print April. What if I decide then that I actually want to print April, May? I have to find all the places where I printed April and change it to April, May. If I were using variables, I would only have to change it where the variable is defined. I would just need to update what's in the jar. If I run this now, oops, there we can see April, May is outputted to the console instead of April. We only have to change it in one place, and everywhere that jar or that variable is used, it has the right value. You can also update a variable's name after you've set it. Let's take a look at an example. We'll say name is equal to April, and then we'll print name, and then we'll say name is equal to April, May. and we'll print name. Let's comment these lines out. And what do you think the output will be? Let's go ahead and run it. We see April printed first, and then April, May. Python programs run top to bottom. So what happens on line 1 is we put April in our name jar. Then when the interpreter gets to line 2, it grabs the name jar and prints out what's currently in it, April. Then it moves on to line 3, where we tell it actually put April, May in the name jar. When the interpreter gets to line 4, it grabs the name jar again and prints the new current value, which is April, May. Now, notice that name is not in quotes. Let's go ahead and look at this example. When we print name in quotes, the interpreter prints name directly. When we have name without the quotes, we print April. Without quotes, the interpreter recognizes that you're creating a variable and it goes to look for that jar. With the quotes, it isn't looking for anything. It knows that the quotes denote a string, so it treats it as literal text and prints those exact characters. So remember, text data goes inside quotes, those are strings, variables do not. Now, how should we name our variables? You are the master of your programs. Nothing's to stop you from calling the name variable n or x or what have you, but it is ill-advised. You want your variable names to be a good representation of the data that they contain. Readability counts, and code is read more often than it is written. Be it by you or a fellow programmer, you want your code to be understandable, and if you come back to your program in a month, it may not be clear what n or x meant, whereas name is descriptive and conveys the purpose. Typically, variables in Python use snake case. This means that it's entirely lowercase, and there's an underscore to separate the words. Names can contain letters, numbers, and underscores, but they can't begin with a number. So something like first place with a 1 would cause an error. One final tip when naming. Avoid using built-in keywords in function names. Here are the Python keywords. I believe you'd get an error if you tried to use one of these as a variable name, but naming a variable something like print won't always cause an error or cause your code to break right away, but it can get incredibly confusing for you and the interpreter. Alright, with that out of the way, let's put our variables to use. Python can do math with numbers, which we'll look at in a later lesson, but did you know you can add strings together as well? This is called concatenation and uses the plus sign. Let's run this example. Here we see the two strings combined in our output. Some things to note. In the first string, there's a space after the word. Let's look at the result without that. Run it again. It squished the words together because concatenation doesn't actually combine words to make sentences. It simply combines strings, taking the literal characters of the second string and adding them onto the end of the first string. But I said let's put our variables to use, didn't I? Let's try an exercise. Create a variable for your name, and then, using concatenation, print hello, your name, how are you, in one line. In my case, I'd want the output to be hello, April, how are you? Pause the video now and see if you can figure it out. Did you get it? Remember that the variable is just holding our data. We can concatenate them just like we do with the strings, because in the case of our name variable, it is just a string. Here's how I do it. Hello with a space, plus name, plus, comma, space, how are you? We can comment that one out and run this. Hello April, how are you? Notice I didn't include quotes around name. That's because we don't want our interpreter to literally print the word name. Without the quotes, it recognizes our jar and replaces a variable name with a value before adding the strings together and printing them. Concatenation works, but there's a cleaner way to achieve the same thing. It's called an F string. An F string lets you put variables inside a string without all of the plus signs. To use an F string, you're going to put an F outside of the opening quote, and then you can just put your variables inside curly brackets inside the string. Hello, name, how are you? And if I run that one, we still see hello, April, how are you? So we've done the same thing, but with a single string instead of having to use string concatenation. I can add multiple variables inside my F string as well. Let's make a fave color variable, set it to purple, and then we can print an F string. Hello, name, your favorite color is fave color. Save that and run it. We see, hello April, your favorite color is purple. You can put as many variables inside the F string as you want. Without F strings, we'd have to do hello plus name plus your favorite color is plus purple. I would have to remember the extra space at the start or end of certain strings. F strings get rid of that headache for us. As your programs get more complex and you're juggling multiple variables, you'll really appreciate not having to manage a chain of plus signs. We've looked at storing information and displaying it. Now we'll talk about the input function. The input function is a lot like the print function, with one major difference. Let's compare. We'll run this with print hello, and now we'll run input hello. Save that and run it again. Did you catch the difference? With print, our program printed hello and then it ended. With input, our program is still running right now, and we have a cursor here. This is because the input function waits for the user to type or input a response. I can type something, and once I hit enter, our program ends. So that's great, but nothing happened. That's because we didn't do anything with our response. The input function took it and sent it back to the program, but the program didn't have any instructions for what to do with it. To actually see what input returned, we could put our input statement inside a print statement, like that. Then if we run this now, I'll say hello there, and it prints hello there. So now I see what I typed printed back. That's because the input function returns a value, the value being whatever the user typed. To actually use that value, we would need to save it in a variable. So let's say user name is equal to input, and instead of saying hello, we'll say what is your name? And you can put a space after so that when you type, it's not right up next to what the prompt was. Now let's run it again. What is your name? April. And nothing happens. Any guesses as to why? Well, we saved our variable, so we could, in theory, do something with it, but we didn't. Let's add a greeting. We'll print hello. Whoops. Need to make that a string, an F string. I want to say hello, username. Save that and run it. What is your name? April. Hello, April. Now we're getting somewhere. I can run this program multiple times with different input every time, and each time it will print hello and then whatever name I put in. Now you try. Write a short program that asks the user for at least two pieces of information, saves both variables, and prints a response in an F string that uses both of them. No right answers here, just make up whatever you like. Did you have any trouble with that? Here's what mine looks like. Got name equals input, what is your name? Fave color, input, what is your favorite color? And then we print an F string with hello name. Fave color is my favorite color too. Let's run it. What is your name? April. Favorite color? Purple. Hello, April. Purple is my favorite color too. Now, what if we switched these two lines? We took fave color and put it before name. Do you think the result will still be the same? Let's run it. Now it asks what my favorite color is first, and then my name. But the print statement is still the same. Remember, the interpreter runs our program from top to bottom. Even though we're using the name variable first in our print statement, the interpreter will create the variables at the line that we define them, not the line we first use them. This means it's going to ask the favorite color first, then the name, and then use those values in the print statement. A quick side note. I've stressed so far that the Python interpreter runs our programs from top to bottom. Naturally, you'd assume that it reads those lines from left to right, but that's not exactly the case. When it comes to the assignment operator, the interpreter is going to evaluate what's on the right of the equal sign first, and then save that value back to the variable on the left. In the example here, when we say print hello name, we don't see hello input what is your name, even though it looks like that's what we're putting in the name jar. Think of it like simplifying in math. The interpreter is going to try to simplify or evaluate what you've typed. So what's actually happening when the interpreter reaches this line is it says, okay, I've got a name jar. What goes in it? Input. Wait, I know what input is. I can simplify that. Let me evaluate input first. And once input is evaluated, I've got a value I can save to the name variable. Another example of this concept is using a variable to update itself. Take a look at this code. Name equals April. Name equals name plus May. Print name. What do you think will be printed? If we assume the interpreter read each line from left to right, this would be a little hard to decipher. Now that you understand it evaluates what's on the right first, it should be more clear. The answer, if we go ahead and run this, is April, May. Our program says, hey, I can simplify that, and it takes our current name value, adds to it May, and stores that, a concatenated string, back in the name variable, giving us April, May. This applies to the earlier example where I put the input inside the print statement. Again, the interpreter isn't necessarily going from left to right on each line. It comes across the print statement and looks at what you're trying to print and if there's any simplification it can do. If so, it'll evaluate that first and then print the result. Another way to think of it is that without our response to the input statement, it doesn't know what we want it to print, so it has to evaluate the input first. With that knowledge, what if I do something like this? I have name equals input, what is your name? And then print hello plus name plus exclamation mark plus input, what is your favorite color? Plus is a great color. Pause the video and think about the code. What do you think the output will be? You may have guessed something like this. What is your name? April. Hello, April. What is your favorite color? Purple. Purple is a great color. But remember, the interpreter is going to simplify everything it can before it prints. If you determine that it would actually ask for both inputs before printing, you're correct. Let's go ahead and run it and see what happens. What is your name? April. What is your favorite color? Purple. Hello, April. Purple is a great color. So let's walk through it step by step. On this line here, the interpreter can simplify input, so it does, and saves our response to the name variable. On the next line, the interpreter can simplify input, so it does that first before it prints anything. Until it simplifies input or evaluates input, it's unclear what we want it to print. So it first prompts us for our favorite color, and then puts our response back into the string and prints the entire string. I know this may seem like overkill, but it's important to understand the ways that the interpreter reads and runs your code in order to write code efficiently. All right, I promise I'm done with the tangents. And with that, you're ready for the challenge. Head to the GitHub repo linked in the description for the story content and the challenge instructions. A solution will be posted there too, but give it a try first. Good luck, and I'll see you in the next lesson.